Alright guys, 6.3 elimination using addition and subtraction. Okay, so here's the deal. We've graphed systems of equations. Then last time we substituted to solve a system of equations. Now what we're going to do is we're going to eliminate. We're going to eliminate a variable and try to get, because the goal of solving a system is trying to get things into one variable. So like only x's in the equation or only y's. Okay, so that's the big goal again for today, for elimination. So some steps to elimination is this. 1, write the system so that like terms with the same or opposite coefficients are aligned. Okay, so in other words, if you have something that looks like this where we have a x plus y equals something and then we have a y minus x equals something, we want to rearrange this so that the x's and the y's line up. Okay, so you got to be very careful here. If you rearrange, the sign goes with the thing that's in front of it. Okay, so this is like a positive y and a negative x. So if I rewrote this one, for step 1, that's what we're trying to do, is trying to rewrite it so that things are aligned. If I rewrote that, it would have to be negative x plus y equals whatever. Okay, so that can be rewritten like that. Step 2 is we're going to add or subtract the equations. Okay, so if we had these two things, and then maybe we should just make them equal to something. Maybe this one's equal to, I don't know, 4, and this one's equal to negative 2, or something like that. What we're going to do for step 2 is we're going to add the two equations together, and notice what happens. If you have an x, and then you add a negative x, or you just subtract x, the x's go away, okay? And you're left with no x's. And then if you add the y's together, you get 2y. And if you add 4 plus negative 2, you get 2. Okay, so now you have this nice equation. And if you divide both of these by 2, you get y is equal to 1. Okay, you can plug the 1 back in to either equation and find x, right? So x plus 1 equals 4. That means that x must equal, subtract 1 from both sides, 3. Okay, so that's the last piece, is that you take your answer and substitute the value from step 2 back into either equation to get your other value for your ordered pair. So final answer in this particular one would be 3, 1. Okay, so that's called elimination. So let's take a look at some elimination using addition. Okay, you use addition when you have opposite signs. Very important. If you have the same sign, you always subtract the two equations. All right, so here we go. Notice in this particular thing, step 1 is done. We have the x's aligned, we have the y's aligned, we have the constants aligned. We're good. Okay, so now what we want to do is determine, do we add or subtract these? Well, I'm looking at the 6y's, seeing that those are the same, but they have opposite signs. So if they have opposite signs, the thing that's going to cancel them, because we're trying to get rid of the y's by adding the two equations together. And when we do that, we can solve for x, plug it back in, and then find out what y is. Okay, so that's kind of the process here. So if I add these together, 4 plus 3 is 7x. Positive 6 plus negative 6 is 0y, so that goes away. Those get canceled. And this is equal to 32 plus 3, which is 35. Okay, to get the x by itself, I divide both sides by 7, and we say that x is equal to 5. Okay, we're not done because we got to plug that back into either equation, so I'm going to choose the easy one, which I think is the second one, to find y. And you can plug it into either one, you'll get the same answer, by the way. So 3 times 5 minus 6y. Notice I substituted the 5 in for the x, is equal to 3. We get 15 minus 6y is equal to 3. We were trying to get this y by itself, so we're going to subtract 15 from both sides. We're left with negative 6y is equal to negative 12. Okay, and then divide both sides by negative 6 to get y all by itself. We get y is equal to positive 2. So final answer to this thing is 5, 2. If you plug a 5 and a 2 into either of those equations, you should get the resulting solutions. Okay, so it's the only point that works. You can check your answers very easily. Okay, so example 1, here we go. Let's look at 1a. So for this one, notice these x's are what I'm going to try to eliminate because they're the same with opposite signs, so I'm going to add them. Okay, step 1 is done. Everything's aligned. Step 2, let's add these together. This goes away. 3 plus negative 5 is negative 2y. Negative 3 plus 5 is equal to negative 2. Sorry, mistake, positive 2. So if I divide both sides by negative 2, I get y is equal to negative 1. Take that, plug it back into either one of these. I'll choose the second one here. So I get 4x minus 5 times negative 1 equals 5. So if we simplify this, we have 4x. If we subtract a negative 5, we're actually adding that 5. Okay, so if we subtract 5 from both sides, we get 4x is equal to 0. Therefore, x has to be equal to 0 divided by 4, which is 0. So for example 1a, our solution is 0, comma, negative 1. Make sure you put this in order of x, comma, y, right? So x, comma, y. Okay, 1b, don't forget step 1, it says. I want you guys to try this one out. Okay, so let's look at this one. So we have 4y plus 3x. I'm going to keep the first thing the same, and I'm going to rearrange the second one. So I'm going to move the negative 4y to the front. Okay, plus 3x. I rearranged these. I switched the order. Is equal to 14. That's totally legal on this side of the equation, you guys. Just keep the sign with it, right? If I add the two together here, this goes away. 3 plus 3 is 6. 22 plus 14 is 36. Divide both sides by 6, and I get x is equal to 6. I'm going to take that and plug it back in. For x in either equation, I'll choose the second one. 3 times 6 minus 4y is equal to 14. So I get 18 minus 4y is equal to 14. Negative 4y by itself, I'm trying to get that y by itself, is equal to, if I subtract 18 from both sides, we have 14 minus 18, which is equal to negative 4. So then y is equal to, if we divide both sides by negative 4, it's equal to 1. So we have 6, comma 1. Okay, so that's example 1. Example 2 says basically we're doing the same thing for example 2, but they want you to use words to create your equation. So we'll do a couple of these just to get used to these again. So the sum of two numbers is negative 10. We can call them x and y. X plus y equals negative 10. Okay, then negative 3 times the first number. So the first number is x here, right? So we can say negative 3 times the first number minus the second number, so minus y, it equals 2. So there's your equations, and now it's a nice system, right? So we can add these together right away because it's all lined up. And if I add these go away. 4 plus negative 3 is negative 2x is equal to negative 10 plus 2 is negative 8. So x is equal to 4. Plug it back in to the first equation. We have 4 plus y equals negative 10. Subtract 4 from both sides. We have y is equal to negative 14. So final answer here, 4, comma, negative 14. Okay, and if you put those into either one of those, you will get the correct answer. Okay, so example 3. So we've done elimination with addition. Now let's look at some subtraction. So what happens when the signs are the same? Here's what I want to highlight. This looks very similar to what we just did, just a little bit different. Notice what happens, you guys. If you try to add these two together, we're trying to eliminate this b because it's the same, right? If you added those together, you get 16b and nothing eliminates, right? If nothing is eliminated, you did something wrong. So let's back that up. And let's try something else. We can, if these are the same sign, the two things that are similar, like the 8b, I can subtract these two equations, and still eliminate. So if I subtract, 8 minus 8 is actually 0. That's what I want. I want to get rid of the b. I'm trying to eliminate it. 3 minus 7 is negative 4c. 11 minus 7, notice I'm subtracting all the way across, is equal to 4. To get c by itself, I divide both sides by negative 4, so c is equal to negative 1. Take that, plug it back in. I'll plug it into the first one this time, so we have 8b plus 3 times negative 1 equals 11. Okay, so that means 8b plus, let's not say plus there, 8b minus 3 equals 11. 8b then is equal to, we add 3 to both sides, we get 14. B is equal to 14 over 8. Okay, so for this one, we all of a sudden, we've been dealing with a bunch of whole numbers. This one, we have a fraction. If I reduce this fraction by dividing both sides by 2, both numerator and denominator by 2, I should say, then I would get 7 over 4, okay, which is equal to 1 3/4, which is also equal to 1.75. So if you get any of those answers, you're okay. And we always put this in order. If there's no x's and y's, if it's b's and c's, let's put it in order, alphabetical order. Okay, so the b would come first, so 1.75 comma negative 1 would be the solution to this one. Or you could have used either of those fractions, right? So example 4, and then you guys are off to the homework here. Tamara and Adelina are throwing a birthday party for their friend. Tamara invited 5 fewer friends than Adelina. Together they invited 47 guests. How many guests did each girl invite? Okay, so this is another example of a system. We can use t and a. So t plus a is equal to 47. This is so this equation is all about the invited guests total, right? This is the total invited guest equation. Then let's modify it with how many each invited. So it says Tamara, T, invited 5 fewer friends than Adelina. Okay, so we could say that Adelina is equal to whatever Tamara invited. So it says Tamara actually invited 5 fewer friends than Adelina. Okay, so let's think about this again. If it's fewer friends than Adelina, then we can say that Adelina minus 5 is equal to T, Tamara. Right? Adelina minus 5 friends is equal to Tamara's friends. So this is in terms of Tamara's friends. Okay, so we have a system here. What I need to do now is I need to rearrange the system so that I can solve it. Okay, so I want a T and an A over there and the 5 over on this side. So let's go ahead and do that. Let's first add 5 to both sides. If I do that, I get A equals T plus 5. Okay, and I'm trying to get things to match up with this, right? So then let's subtract T from both sides. And then I get negative T plus A is equal to 5. Now that I have that, I can align the two. So let's do this in blue. T plus A equals 47, and then negative T plus A is equal to 5. We're going to, you can choose actually, you can add or subtract here. I'm going to go ahead and add the 2. If I add the 2, the T's go away, and I get 2A is equal to 52. Divide both sides by 2 to get A by itself. So A is equal to 27. Okay, so Adelina chose 27 friends. I can plug that back in for A in either equation. Okay, so I'm going to plug it back into the second equation actually. So 27 minus 5 would give me T's. 27 minus 5 is equal to 22. Okay, and let's just make sure that that makes sense before we move on here. Okay, so we have 22 from Tamara, 27 from Adelina. If you add those together, you get 49, right? So something is wrong. Okay, so what is it that went wrong? That's what we got to figure out. hopefully you caught my mistake, okay? So this is, I actually did this, I planned this for you because I want to make sure that you guys are thinking about plugging things back in. Okay, what is 52 divided by 2? Hopefully none of you just took my word on that. 52 divided by 2 is not 27, it's actually 26. Okay, so that throws the whole thing off if a is now 26. Okay, so if a equals 26, then this becomes 26 minus 5, which is actually 21. So if t now is 21, when I add those together, do I get the 47 total guess? Yes, I do. So I'm just showing you there. You can make a simple mistake with your addition and subtraction or division or something if you're not using a calculator, you're not careful. Make sure at the end you plug it back in and it makes sense. All right, guys, that's it for this time. We'll catch you guys.